Hello all, welcome to the next topic from electric field and the charge chapter, first Ncert, first chapter from second year. So last class we have discussed about various concepts from electric field intensity. Mainly the last topic we have discussed about the point at which the electric field intensity will be zero if it is two charges are similar charges, either it is positive or both are negative, then the electric field 0 point is the intermediate positions between the two charges and it's very closer to the lower charge. And the second concept we have discussed, when if it is two different charges, if it is two different charges, then the electric field intensity point 0 point is located left to that of the charge which is having the lowest magnitude. This is what we discussed, and today we are going to discuss another important concept, which is nothing but the variation of electric field intensity with respect to distance. This is normally these questions are normally I have seen for AIMS and JEE kind of examination. Even for Neet also there are chances to ask these questions, and the questions are a little bit tricky. So if we are understanding the concept fundamentals very well, it's easy to figure it out. This whole topic is related with some graphical representations of variation of electric field. So let's move. So write down the heading: variation of electric field intensity with distance. You can put it as R, distance. Okay, so we know the general equation of electric field intensity, E equal to 1 by 4 pi epsilon 0 Q divided by R square. This is nothing but the electric field created by a charge at a distance of r meter from here, and at this point the electric field is E, and this value of E is given 1 by 4 pi epsilon 0 Q by R square. Here we know E is proportional to 1 by R square, which means when the denominator, the distance is increasing, this factor E will be getting reduces. So this is what is the fundamentals from this equation. Okay, so E is proportional to 1 by R square. We are applying this concept to learn the things. Okay, I just brush it up what we have learned in the previous class. So we'll move to this one. Here write on the first subheading. I am giving first subheading as A. So give the subheading: variation of, write down along with me, variation of E for a single positive or a single positive charge. Variation of E for a single positive charge. Variation of E for a single positive charge. Before going to this depth of the topic, we'll understand normally for all my lecture videos so far I told whatever it is going in the positive x directions are taken as positive, whatever going in the negative x directions are taken as negative, which means electric field towards right side is considered as positive and electric field towards left is considered as negative. This is a normal sign conventions I am using throughout this chapter. So the same concept, whatever coming left is negative, whatever going right is positive. So we'll see variation of electric field for a single positive charges. So let's consider I have a positive charge plus Q will be here, located will be here. I am plotting these on x and y axis. Okay, just assuming the point charge is located at the middle or at the origin positions, then what will happen to the electric field intensity? So electric field intensity is a plot between the electric field and the distance, the radius vector or the distance vector. Okay, here it is positive R, here also it is negative R, variation. So that is negative x-axis and it is positive x-axis. This is plus E and this is nothing but minus E in the reverse direction. So this is nothing but an E axis. We can represent it as plus Y and this is minus Y, this is minus X and this is plus X axis. But this is a distance line and this is an electric field line. Now we'll see. For a positive charges, electric field lines are always going out. Electric fields are going out. So if I am considering the graph Y part as two part, one is this left side part and another one is the right side part. In the right side part also, left side part also, electric field lines, I am just drawing here. For a plus Q charge, electric field lines are always going out. Okay, so if you're drawing one line like this, you can see right side is always going towards left side it is always going towards left. So the electric field for a positive charges, it is if the distance is very less, origin distance is 0, if you are going away from the origin, the distance R is increases. When R is increases according to these equations, electric field is reducing. So at this point R is very less. If R is very less means electric field is more high. So which means nearer to the charge, electric field is more high. When distances is keep on increases, electric fields are going down like this. Okay, this is for positive R. So whenever I am considering the negative R means in the other side. So in this side, so here electric field is in this direction. And here in this side, according to this diagram, electric field is towards left. Whatever coming towards left is considered as electric field negative. Whatever going towards right is considered as electric field positive. So it is now electric field is towards left. Left means negative. So nearer to the positive charge, electric field is higher value. If you are going away from the positive charge, what will happen? This electric fields will be reducing. So this is a graphical representation of variation of plus Q. I am repeating once again, for a positive charges, nearer to the positive charge, electric field will be very high. If you are going away from the charges, what will happen? Electric fields are reducing. The graph is going down like this. And in the other side, this electric field lines are going out, which means it is going in the negative x direction. If it is going in the negative x direction means electric field is negative, but nearer to the charge electric field is maximum. But if you are going away from the charge, the electric field is reducing according to the equation E proportional to 1 by R square. So this is the graphical representation of variation of electric field for a single positive charge. This is a single positive charge. Okay. So we'll move to the next one, the next subheading. Okay, I can say the subheading between I am writing, you can also try yourself. Next subheading is variation of electric field for a single negative charge. Now we have a positive charge, the graph is look like this one. Now for a single negative charge. So I am taking the sides of the board. Okay, so let's do this will be here. So the second heading, variation of, I am writing here, variation of electric field due to a single negative charge, due to a single negative charge. So same as like this one, we are drawing the diagram. We have a minus Q charge located here. I am plotting the graph. This is plus axis and this is the y axis and the x axis, and here is a distance vector and here is a electric field vector. Okay, now here we have to see, in case of a negative charge, we will take a negative charge. In case of a negative charge, what is the electric lines of force? This is different from this one. For a positive charge, electric field lines are going out. For a negative charge, electric field lines are coming inside into the charge. Okay, so all lines are coming inside. So if you're considering the right side, the electric field lines are coming like this. So which means this electric field directions are towards left. Left means negative. So E is negative. But here also the electric field lines are going inside. So inside means towards right. Right means positive. Okay. So right means positive and left means negative. So now we know when distance will be reduces, electric field will be very high because E is proportional to 1 by R square. Now negative, so negative E has to taken care will be here. So at very short distance electric field will be very high. When distance increases, electric field will be going down. This is the electric field, right? So electric field will be very high value at shorter distance. When distance increases, you can see this electric field. This is like electric field. So this electric field will be getting reduces like this. Now other side, electric field is positive because it is moving towards right side. So electric field is positive. So when distance increases, electric field will be reduces like this. So this graph and this graphs are exactly opposite. Whatever you have seen for plus Q is different from whatever you have seen for negative Q. Never by heart like this one. Okay, for plus Q first quadrant and third quadrant, for negative it is second quadrant and fourth quadrant. No. Never by heart it's something like a shortcut method. You will never ever forget because you are learning many chapters and between you will get confused. But understand the concept. Whatever going left, E negative, so you put it E negative. When distance increases, E will be reduces. When come to here, going right side is positive. So electric field always on the positive y axis. So when distance R is increases, electric field will be reduces, going down like this. This is a fundamental. So for a positive charge we have learned, for a negative charge we have learned. Now we'll go to the, hope you understand the subsections of A, the subsection A and subsections B. We'll move to the next subsection. Write down the next one, C, the third one, C subsection. What will come? C. Now we are just playing as like mathematics. Once we know the additions, we can do any number of additions of any two numbers, right? If you know multiplications, we can do any number of multiplications number. The same logics. Now we are just playing with this one. Now I know how plus Q will behave, how minus Q will be behave. Now I am doing some stuffs. Between plus Q combination, between plus Q minus Q combination with a different magnitude, with the same magnitude, we'll say. So we'll move to the next one, the third one, C. Variation of, again the same heading continue, slight difference. Variation of electric field due to two charges. Each charge the properties. What is the properties of the two charges? Variation of electric field due to two charges. Two charges, same magnitude, okay, same magnitude and same sign, same magnitude and same sign, which means I am taking two charges, both are equal magnitude. So plus Q and plus Q. Drawing the graph. So this is like an x-axis for this one and this is a y-axis for this one. So if it is any number of multiple charges coming, you don't want to worry about the multiple systems. Only you have to worry about what is a charge. So it is positive charge. So electric fields are, look one by one, starting from either right or left, up to you, up to your wish. You can start from any side, but one by one, so that the complete diagram can be drawn. So we'll move to this. I'm starting from the right side. So electric field is right side because it's positive charge. It is pushing electric field away from that one. So this is positive. Okay, here also the electric field, because of this one, it is pushing towards left, so it is negative. Mark this one, so easy to draw. Then we'll complete. So we know this is called the distance vector or the R vector. So whenever the electric field is positive, means when distance increases, this will go like this one. Here electric field is negative, so we have to start from negative. So negative graph will come like this one. Okay, now here also electric fields are pushing towards right, so it is positive. And here also electric fields are pushing left side, so it is negative. Here also it is positive, means the graph will come like this one, but but here there is a point will be here. What is this indicate means? Here at this point the electric field intensity will be equal to 0, which means the positive charge will push electric field like this, and this positive charge will also push electric field will be like this one at certain point, exactly at the middle. If the magnitudes are same, definitely exactly at the middle, the electric field created by the left side charge is equal to electric field created by the right side charge. Both are equal magnitude and both are in opposite direction and cancel each other, so the net electric field will be equal to 0 will come. Here it is E negative, so the graph will be like this. So this is a complete graph for a plus q and a plus q combination. The same things will take if you are taking plus 2q plus 3q, any magnitude, but both are having same magnitude and same sign conventions. So C part is over. We'll move to the next one, D1. The sessions D. Okay, what's the sessions D is talking about? D is talking about variation of electric field due to. So variation of electric field due to two charges. Same way, due to two charges. Only difference, I am not taking same magnitude, different magnitude and same sign, different magnitude and same sign. So plus q, same sign, either both are positive or both are negative, but we are now going with the same sign, means which are positive in nature. Same sign within bracket you may write both are positive, In this third heading also we will correct it here, we will write additional information. Both are positive, because in the next subheadings we can say both are negative cases also. Now both are positive cases. So plus q charge plus 9q, different magnitude, distance like this, distance vector is like this, and electric field is on the y-axis. We are going to draw the diagram. Next, plus 9q. Plus 9q will be here, right? Correct. Electric field right side, what will happen? Electric field will be pushing. So right side the graph will come like this one. Left side it is pushing away, so graph will come like this. So this is also clear. Here also it is plus q, magnitude like this. Electric field will be coming like this. Here electric field will be coming like this. Exactly similar, but the only difference is that the electric field created by this will be very high, very near to the charges. But electric field created by these charges very near to the charges will be less. Why? Because E is proportional to Q by R square. Distance between will be same. If I am moving 1 meter here, if I am moving 1 meter will be here. Suppose you assume 1 meter I moved from here. You moved 1 meter from here also. So you are exactly at the same point, 1 meter from plus 9q, and you are 1 meter from plus q. Where electric field will be maximum? I can say electric field will be maximum here. Why? Because q is a numerator. Magnitude of the charge will be higher for this 9q. So electric field will be very higher. Here electric field will be very lesser. So whenever it is moving away from the charges, R will also increases. When R will also increases means the electric field created by the charge 9q will also get reduces. So what will happen in this case means there is a null point will be there similar to this one, but it is not exactly at the center. It is very closer to the lowest charge, because here it will create one electric field. That electric field will be equal and opposite to the one created by the high magnitude charge. Both will get cancelled, not exactly at the center, but it is very closer to the lowest charge. So the electric field will become equal, and these electric fields are created by the lowest charge and the highest charge. But in this case magnitudes are equal, so electric field will be exactly cancelled at the center, but here is not like this one, it will cancel at the lowest charges, okay, nearer to the lowest charges. So A, B, C, D over. Next one is, what will next one will come? E. The next session is E. the third subsection, the next fifth subsection is E. What's the difference we are going to see will be here? Variation of electric field due to two charges, same magnitude and same sign, but both are negative. We'll take two negative charges, minus q charge here and minus q charge here. So we are drawing the diagram like this. Okay, so electric fields are always attracting toward this one. So here electric fields are coming like this, electric fields are coming. So this electric fields are coming towards this one, which means towards negative direction. Here electric fields are going towards positive direction. Positive direction means positive. Negative direction means electric fields are like this. Here also negative charge. So electric fields are coming like this, electric fields are going like this, coming. Okay, both are coming inside. Electric fields are always coming. So this is what sign? E, positive sign. This is what sign? E, negative sign. So here it is E negative. E negative means here. So this will come and this will exactly cancel at the middle as like the previous case. Here E positive. Positive means like this. Electric field is positive like this. So this is a graph for variation of electric field due to two charges, same magnitude, same sign, but both are negative. Okay, so E is over. We'll move to the F section. F, variation of electric field due to two charges, different magnitude, same sign, both are negative charges. So we'll remove this graph and we'll draw. You can also try. You don't want to wait until I am trying. You can also try. So minus q will be there, minus 9q will be here. Both are negative. Both are negative charges. Both are negative charges. Okay, so both are negative charges means minus 9q, it is towards left and electric field is negative, and here towards right electric field is positive. Electric field is negative means here it's like this. Electric field is okay, here it is electric field is negative, here it is electric field is positive, so it's like this. Minus 9q, electric fields are towards the charge always, so this is E negative and this is E positive because it is towards right. E positive means electric fields are like this, E negative means electric fields are like this. But again there is a cancellations point will be there. Where it will cancel? It's cancel very closer to the lowest charge. So here electric field will be equal to 0. Here also electric field will be equal to 0. But what is the difference? Here it is exactly at the middle. While you are drawing also it should be at the middle, but here it is very closer to the lowest charge. Graph will be getting changes. So A, B, C, D, E, F, 6 cases we have seen. We'll move to the next cases we will do together. While I am drawing also, you also try to draw. Okay, so E, F. Next one is G. Write down the next heading. Variation of electric field. Variation of electric field. Variation of electric field. A, B, C, D, E, F over, right? So G. Variation of electric field due to two different charges. Two different charges. One is positive and another one is negative. Two different charges. We'll keep it as two different charges. So plus q, you can consider the same magnitude, different magnitude. You can try all this case. That's what I told. You can do any number of combinations. All these combinations one by one can ask for the NEET examinations or JEE examinations, whatever you are writing for the entrance examinations. So here electric fields always attracting, so E is in this direction, so which means it is negative. Here electric field is in this direction, so E is positive. We'll complete this diagram. E is negative. Negative means like this, and E is positive, which means like this. Okay, maybe so this is over, and here due to plus q, what will happen? due to plus q, the electric fields are going away. So E is positive will be here, and electric fields are going will be here left side. So E is negative, always away from the charges. And for this one I am using a different colors. So plus q means E is positive, so positive means graph will come like this, and here electric field is negative, so graph will come like this one. So depends upon the question. Now you can see this is like a U-shaped graph, right? Here it is U-shaped when both are equal magnitude. You can try when both are different magnitudes and other cases also. So this is the fundamentals of this one. Once you know how you are drawing the diagram for plus q and minus 9q, based upon that you can go with this. Total 7 cases we have learned, right? Total 7 cases, A to G cases. So all these A to G diagrams are important. We don't know which diagram is going to come for the NEET examinations, but all these diagrams are just like playing a mathematics. That's what I told. So once you understood how you are drawing the diagram for a plus q or minus q charges, the variation of electric field, if you know that fundamentals, you can draw it for any other combinations which is coming for examination. Mostly whatever I have covered will be here, 7 cases will be there. Any one of the question will be falls under any one of this category. Okay, so try to learn it, draw it in the notebook. Different combinations you can try. Still you can try a lot of combinations, both are negative, different magnitude. Already we have seen all these things, but all the 7 cases you try to recollect it and try to you can write different combinations of heading, and you can write one. So this is a whole concept from the variation of electric field with respect to distance.